Okay. Hi. So my name is Robin, and my talk is a little bit off topic. It was also planned for 15 minutes, but I guess where it intersects with the security is when it comes to disclosure and transparency. So what happened is I was in Japan last year during the earthquake. March 11 was, I mean, huge earthquake, tsunami. You all heard about it. Problems. So obviously a power plant blew up. That's what's in the picture. Unknown situation. I mean, maybe there's radiation, maybe there's not. There's an outstanding lack of transparency from the government. There's no information. Nobody knows what's the situation on the field. Problem, no equipment. So Geiger counters were sold out in, I guess, 1 week after the earthquake. Not in Japan, not in Switzerland, not anywhere. What do you do? So solution is get your soldering irons, make sensors, but mobile sensors, where you can put them on a car and just drive around. So distribute these few sensors to volunteers. Lots of people with very high motivation to discover what's around them. And then create open maps. So these are on the right, the Tokyo Hackerspace with the people working on the sensors. So the sensor design we had was fairly simple at the beginning. You take a Geiger counter, GPS, use Arduino to collect pulses from the Geiger counter, aggregate, get a pulse count, use processing on the netbook, and save all this to a file, upload it online, make a map. Simple. Fairly big, fairly bulky USB cable getting in the way in the car. Hopla. Can make it smaller, just keep the Geiger counter, the GPS, use an SD card, Arduino, save to file, make a map. Now, so on the upper left is, on the very left is the one, you can see the USB cable, the first prototype. The second one is a self-contained sensor. So it fixed to the car by winding the window on 2 straps. So this is the same thing. There's a Mylar window to let the radiation through. And what you obtain is drive-by science. So I guess you're familiar with drive-by, Wi-Fi discovery and stuff. So we do that with radiation. You can do it on bike or on foot. So this was in the exclusion zone. A very courageous person going there to collect data. So what's the efficiency of this system? It's actually great. So we started roughly 1 month after the earthquake. After 2-3 months, we have 500,000 measurements. Today, we're over 5 million points. It's the biggest data set that has ever been collected. So we have an API, api.safecast.org. So the goal is to allow, in the future, crowdsourced measurements. People can upload their file. There's a moderator system where we can check, roughly if we think it's valid or not, and decide to keep it or not. So different option, visualize it, make a map. And all of this is a CC0. Basically, it's public domain. You can download the whole data set. We hope it will be used for science by universities and research. So we also do all the hardware, the software. Everything is open source. You can get the CAD files, the firmware, the map visualization tools. All of this is on GitHub. So please visit, and if you like to contribute. So this is also a new visualization. So this is just Japan, north of Japan. So there is the power plant, and we can clearly see the trace of the explosion due to weather patterns. And over here, I think it's Tokyo. So, compared to having no information, this is really helpful. Lots of people would have banned completely, food that was grown in the north of Japan. That's also where all the agriculture happens. But actually, you can see that it's not such a clear-cut case. So really, depending on very fine-grained localization, the situation is very different. Now, we evolved the equipment, and we have a kit, actually, that will be for sale soon on Adafruit. Basically, it's just Arduino with GPS, some OLED screen, SD card, and rechargeable lithium battery, very small. So hopefully this will be. It's over?
Okay, go on.
Okay. We have also open source Geiger counter. So this is a handheld Geiger counter. Stickers. So the idea is you can measure, put the sticker, crowdsource radiation measurements. This is all thanks to lots of volunteers that are pictured here. Small picture, actually much more people involved. And thank you.